Hey everyone, so in this video we're going to go over how to create linear equations given two ordered pairs. So remember that the slope-intercept form of a line is y equals mx plus b, where m is the slope, m is the slope, and b is the y-intercept. So in this video, we're going to just be breaking down these terms a little bit further and also introduce the x-intercept of a line as well. So the slope, remember, is what we usually call m in the slope-intercept form. And this is the measure of steepness of a line. Measure of steepness of a line. All right, and if we're given 2 points on a line, we can also find the value of the slope by finding the rise over the run. So m equals the rise over the run. So let's see that graphically. So let's plot an arbitrary line, call it L, and let's choose 2 arbitrary points on this line as well. So I'll first choose this point and we'll give it coordinates x1, y1. And then we'll choose this point and this will be x2, y2. So to find the rise, this is the vertical change. So when we're discussing vertical changes in the xy plane, this refers to the change in the y values or along the y-axis. So rise references the y coordinates. So this is rise, and x, or rather run, refers to the horizontal change or the change along the x-axis. So this is run. And so if we were given 2 points and we wanted to find the value of the slope, we can do this using those 2 points by just saying that the rise is equal to y2 minus y1 over x2 minus x1. So the key idea to remember here is that m is equal to the rise over run, and that we can find the value of the slope if we just subtract the 2 y coordinates and divide it by the 2 x coordinates. Moving on to the y-intercept, this is usually known as b. In the slope-intercept form, so b. And this is the point where the line intersects the y-axis. So point where the line intersects the y-axis. So let's see this graphically again as well. So we have this line. Where does it intersect the y-axis? Right here. And also a key thing to remember is that we can always write the y-intercept as an ordered pair as well. And so always can be written as the ordered pair 0b. So if you have an equation in slope-intercept form and you're asked to find the y-intercept written as an ordered pair, you know that it's just a point along the y-axis, and points along the y-axis always have the form 0 and then the y-coordinate. And then if we are also ever asked to find the y-intercept, we can always use a solid method of substituting 0 for x and then solving for y. So we can also substitute x equals 0 and solve for y. So this is just a few methods on how we can find the y-intercept of a line. We can write this as 0b. For the x-intercept, instead of the point where it intersects the y-axis, now will be the point where the x-intercept is the point where the line intersects the x-axis. So I'll also draw this arbitrary line. And where does this line intersect the x-axis? Right here. Oops. I'll change my colors for x-axis. All right, so the point where the line intersects the x-axis. And we can also write this as an ordered pair as well. And so remember that ordered pairs for points that lie on the x-axis, the ordered pair always takes the form the x-coordinate and then 0. So can always be written as x0. And lastly, if we're again asked to find the x-intercept when we're just given an equation, we can do this by substituting 0 for y and then solving for x. So can substitute y equals 0 and solve for x, and that will give you your x-intercept. This has the ordered pair. Excuse me, it's x0. We'll call it x10. All right, so that's a little information on x-intercept, y-intercept, and slope. So let's move on to a few examples. So the first example just being, we're tasked with finding the slope passing through, of the line passing through the points -4, -5, and 8, 1. So remember that the slope is also known as n, that is equal to the rise over run, which is also equal to y2 minus y1 over x2 minus x1. And so what is x1, x2, y1, and y2? So here we have x1, y1, x2, y2. And let's just substitute these values into the corresponding place in the slope equation. So y2 is equal to 1. y1 is equal to negative 5, and x2 is 8, and x1 is negative 4. And remember that whenever you have a minus a negative, this turns into a plus. So we have, I'll just rewrite this. This turns into a plus. So we have 1 plus 5 is 6. 8 plus 4 is 12. And this reduces to 1 over 2. So we know that the slope of the line that passes through these 2 points is 1 over 2. So let's think about this graphically as well. So let's plot the points. We have negative 4, negative 5. I'll roughly sketch this. So I'll say this is around negative 4 and this is around negative 5. Negative 4, negative 5, and then 8, 1. So that'll be like around here, 8, 1. And connecting the points, we have our line. And remember to find the rise. The rise is we have to move 6 units up. So this is equal to 6 units up along the y-axis, and then the run. Oops. We have to move 12 units along the x-axis. So the run is equal to 12. So our slope is 1/2. Or in other words, our rate of change, what we're constantly adding by, is 1/2. Moving on to the next example, now we're tasked with finding the entire equation of the line that passes through the points. So it's always nice to start with what we're exactly looking for. So we're finding the equation of the line, and so we usually write these equations in slope-intercept form. So we're trying to find what is y equals mx plus b, and in finding the equation we have to find n, the slope, and we have to find the y-intercept. And so we can follow the same process as the previous example for n, so n equals y2 minus y1 over x2 minus x1, x1, y1, x2, y2. y2 is 3 minus y1 is 12. x2 is negative 1 minus x1, which is 7. This becomes 3 minus 12 is negative 9, and negative 1 minus 7 is negative 8. And a negative over a negative becomes a positive, so this is just 9 over 8. So now we just found m. And it's always nice to maybe write a solution box for m and b. So we just found m, which is 9 over 8, and we're still left with finding b. So we can write y equals 9 over 8x plus b. And how we can find b is by substituting one of these points into this equation. So let's choose the first point, 7, 12. So y in this case equals 12, and 9 over 8 times x is equal to 7 plus b. And so now we'll solve for b. So this becomes 12 equals 9 times 7 is 63 over 8 plus b. And so then I'll move this work up here. So this becomes 12 equals 63 over 8 plus b. And we want to subtract 63 over 8 to get b by itself. All right, so 12 times 8, 60 plus 36 is 86 over 8 minus 63 over 8 equals b. So what I did here is I created a common denominator so I could add or subtract these two numbers together. If you want a refresher on adding or subtracting fractions, approach me in class and we can go over an example as well. All right, this becomes 33 over 8. So b equals 33 over 8. So now we can fill this in here. So now that we have our m, we have our b, we can plug this into the slope-intercept form. So y equals 9 over 8x plus 33 over 8. And what does this mean graphically? Well, let's plot the points again. So this will be roughly 7, 12, and negative 1, 3 looks like this. So negative 1, 3, 7, 12. And this line is what we just found. If we plotted this on Desmos, this would be y equals 9/8 x plus 33 over 8. So this is the solution. And I'll continue with the last example in the next video. Thanks, guys.